Hello and welcome to another video. In this video we're going to be going over the problems from Weekly Contest 407, and let's get started. So in this one, the first one, you have two integers n and k, and you want to turn n into k, not the other way around. And the only operation you can do is change ones in the bit representation of n to zeros. So they just tell you like how much can you do this. And so, yeah. So basically you need to know how to turn a number into binary, which is pretty easy. So if you have some number into binary, like let's say it's represented like this in binary, you want to get the last bit by ANDing it with 1 or dividing by 2, either one. So that'll give you a bit. And then you can either divide it by 2 or shift it to the right. Or actually, sorry, last bit modding by 1 or ANDing with 1. We'll give you the last bit. And then you want to get rid of the last bit by shifting to the right or dividing by 2, so that'll get rid of that. So basically you get, in some way get that bit representation of n, get that bit representation of k. Let's say this is n, let's say this is k. Then you just look for every bit that's in n, that's a 1, that's a 0 in k, that's going to be like one operation you need to do. And then if you ever have a bit that's 1 in k and 0 in n, then you can't change it. So for example, if this is n and this is k, like here, k has a 1 and n has a 0, and the only operation you can do is change ones to zeros. So this would basically be impossible. So this is basically what you do. So while these numbers exist, while there's still more bits, get the last bit of each number. And then if the k bit is 1 and the n bit is 0, then you can't do it. If the n bit is 1 and the k bit is 0, you add 1 to the result, and then you shift it to the right, and you just keep doing that. So basic bit manipulation. Okay. Next one. Yeah, I think a lot of these in this contest were like just pretty straightforward, I feel like. I will say the bi-weekly contest was like really long. Well, I did a few problems. I didn't do the whole thing because I thought it was going to take forever. So like the first person finished in 30 minutes. That's probably going to take me like 3 hours or something. I was like, I have too much stuff to do. So I'm not going to do that one, but this one definitely is quite doable. Yeah, so in this one, Alice and Bob are playing a game and you have a string. And what you can do is you can remove non-empty substrings from S that contain an odd number of vowels for Alice and an even number of vowels for Bob. First player who cannot make a move on their turn and lose the game, we assume they play optimally. And so the vowels are this. So basically here, like here's this example. So Alice would remove this guy, and then there's one vowel left, so Bob can't remove it. And here there are no vowels, so Alice can't do anything. So this one is pretty straightforward once you realize kind of like what this problem boils down to. So if you have some word like this, I guess let's only use characters. So whatever, some word, right? And that word has X vowels. There's always a way to remove substrings to get rid of a number of vowels from 0 to X, right? So they do have to tell you have to remove some number of vowels. So actually you can't remove 0, but you can remove 1 to X vowels pretty easily because you can just figure out like where the vowels are and just remove a word big enough to remove whatever you want, right? Because like let's say you have, like let's just make it in terms of zeros and ones. So like this string here has 1, 2, 3, 4, 5, 6, 7, 8 ones. Let's say the ones are vowels. There's a way to get rid of 1 through 8 vowels, right? If we want to get rid of 1, we can get it like this substring. 2, 3, 4, 5, 6, 7, 8. So basically all we care about is the number of vowels, and it's always possible to get rid of up to all of them or 1 in just one substring. You can just pick like a substring that contains that many. And so the trick here, and I don't even think it's not super hard to realize, but basically Alice has to remove an odd number of vowels. So basically this just boils down to I have some number of vowels X. And as Alice, I need to remove some number of vowels so that Bob can't remove an even number. And so it's pretty straightforward. Basically, if there's no vowels, then Alice can't do anything. But if there's an even number of vowels, so there's 10, Alice can just remove every vowel but one. So Alice would remove an odd number. And then Bob can't remove one because Bob has to remove an even number. So if there's some even number, Alice can just remove x minus 1 vowels. And then Bob will have one left, and then Bob loses. And if there's an odd number, any odd number, Alice can just remove them all. And then Bob will have 0, so Bob will lose. So basically, because Alice goes first, as long as there's a non-zero number of vowels, Alice always wins. And that's all you have to do. So you literally just look for, does this thing have a vowel? If it does, Alice wins. So that's a simplification. Yeah, so I think this was like one of the easier questions asked. Like once you realize like what you have to do, it's like very straightforward. It's literally just, do you have a vowel? Okay. Okay, so the next one, you have a string of ones and zeros. And you can perform an operation where you can either move a 1 to the end. So if you have something like this, let's say, you basically have an operation where you move a 1 until it hits another 1. So in this case, there is no 1. So you're going to move it to the right all the way, and then you're going to put it here. So you can pick any of the ones and move it until it hits another 1. So if you have something like this, for example, if I say let's move this 1, then this 1 will move until it hits this one. So it'll move right before it. So it'll move over here. And so there's a couple things to realize here. So if they asked you, what's like the least amount of like movement you have to make to move all your ones to the end? So the best operation for this, and there's like, I think this is just like intuition, is you're always going to want to move the 1 to the right first. So basically what you would do is you'd start here, and then you'd say like, okay, so if I want to just minimize distance traveled for all the ones, I'm going to take this one, it's going to end up here. And then I'm going to take this one, it's going to end up here. So swap these. Then I'm going to take this one, it's going to end up here, and so on and so on. But basically, so one other thing you can realize for this problem is, like if I have this or this, it doesn't really matter because they're not asking you to calculate distance, they're just asking you to calculate like how many moves will you make. So in one move here, the 1 will go to the end. And in one move here, the 1 will go to the end, and you can't do anything else. So if there's a bunch of zeros in a row, that can basically be treated as 1 0. And so if you have a bunch of ones, so now that you know, I guess all bunch of zeros in a row are the same as 1 0 because one move will take the 1 and move it past all the zeros in a group. So now we can like rewrite these strings, for example, as just every group of multiple zeros is just 1. So let's say we have this. So this one's already here. So you can move these ones some more, right? So I can either like move this one to the end, or this one, or this one. And basically, like what would maximize the number of actual moves you make. So let's just say we always take the rightmost one and move it. So let's do that. So in one move, we'll get this, right? Where we take this guy and move it to the end. So that's one move. Then in another move, we'll get this. Yeah. And then finally, we'll get this. So that's 3 moves. And if you want to minimize the number of moves, you're always going to want to move just the one to the right first. And that would basically always take whatever ones can get moved, that would always take that number of 1 moves. Because you're not like moving any number multiple times. But if you want to maximize moving your stuff as many times as you can, you basically do the opposite. So if we have this, instead of moving the rightmost one first, you always move the leftmost one first. So you're going to move the left one, and it'll go here. Now you can only move one of them, which is the rightmost. So you're forced here. Now, still the right. And now the left. And so notice here, we moved this one twice. We moved it here first, and then we moved it again. So this is 4 moves total. So with this, you don't actually need to move them. I mean, you could, but you don't need to move them. You basically need to realize that if I have a bunch of ones separated by zeros, what's going to happen here is I can just count up how many of these. So any sequence of 0 I'll refer to as a gap. So here we have a gap. And basically, any one of these ones that will move to the right is going to cross all those gaps. And if I do it the least optimal way possible, every single one will cross only one gap in each move, I think. We'll double check this. So basically there's like gap number 1, gap number 2, gap number 3. And then for each one, you can just figure out like how many gaps you need to cross cumulatively. So this one's already in place, so you don't need to do anything. Then we are into like a gap of zeros. Then this one crosses one gap because we only have one gap of zeros. Now we have a second gap of zeros. So this one's going to cross two gaps of zeros. So we have 1 and 2. Now there's another gap. So this one's going to cross 3 gaps of zeros. So the last one should take 1 move, and then 2 moves, and then 3 moves. So basically, you can just keep adding on gaps. So anytime you hit a gap of zeros, you add to your gaps. And anytime you add a 1, you can say like that 1, if I do the worst movement sequence possible to maximize the number of moves, that one's going to cross all the gaps. So let's show this. So like I said, this should be like 6. So the worst thing you could do to maximize the number of moves, or like it's the best thing, is always move from the left. So our first move is just going to be this. That's one move. So notice how this one fell into this gap. Then it's going to fill into this gap. Then it's going to fill into some other gap. And we'll see that. So that's one move. Now we can move this guy because the other one's not available. So 0, 1, 0, 1, 1, 0, 1. Now we're going to move this guy again. So you see how we moved it twice now. 0, 0, 1, 1, 1, 0, 1. Now we're going to move the right one because that's the only one available. Then the right one again, only one available. And then the left one. So notice that this one right here moved here, then it moved here, then it moved here. So we moved it 3 times. This one moved 1 time. And this one moved twice, I believe. So let's see. Yeah, so it moved here, and it also moved here. So that's correct. So if we write above these the total number of moves each of these moved, this moved 3 times, this moved twice, this moved once. And basically that's the number of gaps. So here's 1 gap, now we have 2 gaps, now we have 3 gaps. So hopefully that makes sense, and you can play around with this to convince yourself that's the case, but basically that is the way it is. The least optimal is left to right, and the most optimal is right to left in terms of number of moves. At least that's what I came up with, and I haven't found like a disapproval of that. So, and this is like, I don't know if this is like greedy. I guess it's kind of greedy. Yeah, you can basically realize like, okay, like first you have to realize like what's the least intuitive way to move it, and they kind of show it here, right? So they take this they take this left one and then they move it, and then they move the other ones, and then the left one moves multiple times. Because if you move from the right, then every number will go right where it needs to go in one operation. Okay. So the code, pretty easy. So basically, if there's a 0 at the end, there will be a gap. So if we have like this, there will be a gap because this one still has to move. So if there's a 0 at the end, there will be a gap. Then we just go through all our numbers. And we don't want to count multiple zeros twice. So if we have something like this, for example, this is still only 1 gap. So anytime we hit a 0 and there was another 0, we don't want to count that. We only want to count gaps is if we hit a 0 and then there's a 1 after it, which is this. So basically just count up the number of total like groups of zeros as you're going right to left. And then anytime you hit a 1, that 1 is going to move the number of gaps to its right. So pretty straightforward. Okay. Last one. Definitely not an 8-point problem. This is one of the ones that's absolutely not an 8-point problem. So let's get into this one. So you're given 2 positive integer arrays, nums and target, of the same length. In a single operation, you can pick a subarray of nums and increment or decrement. Return the minimum number of operations required to make nums equal. So in this case, basically what we can do is we can write out like a difference array just to visualize it easier. So like here, we're gonna need to add 1, add 1, add 1, add 2. And so there's a few ways you could do, actually no, there's only one way you could do this in 2 operations. So you can pick a whole subarray. So you could say like, let me just increment this whole thing by 1. Then I'm only gonna need 0, 0, 0, 1. And then let me just take the last guy and increment by 1, right? So increment all of these by 1, then increment the last guy. Okay, so how do you do that one? So like, how would you pick subarrays? It doesn't really matter how you pick subarrays, and you can just do like a, I don't know if it's a greedy or something, but you can just go left to right, and there's going to be a few cases you run into. So I'm just going to write out these difference arrays because we don't really care about the nums target. All we care about is like what we have to increment and decrement by. So first example, let's say we have something like this. Let's say this is our difference array. So as we go and we hit the same number, we know we can combine it all into like the same group, right? So as we keep going, we're just going to be like, oh, this takes us 1, this takes us 1, this takes us 1. But now what happens when we hit a 2, right? So we had some smaller number, and then it goes to some bigger number. Like what do we do in this case? And actually, all we have to do in this case is just keep track of the bigger number. Because if you have something like this, it's always going to take the bigger number of operations. Because what you can do is you can just say, okay, well, let me just take that whole array, increment by the smaller number as many times as I need to, right? Or increment by 1 smaller number amount of times. And then let me take the rest of the array and increment it smaller number minus, or bigger number minus smaller number amount of times. So basically I'll have smaller number of increments plus, then I still need this section, which is the bigger number minus smaller. And you can see this cancels. So the total number of increments I'm going to have is just a bigger number. I'm not incrementing the whole thing by the bigger number, but I'm going to need that many operations. So that's that case. Now what happens if we go the other way? So here, obviously this will still take the same amount, but the problem is, in this case, there might be some like we basically need something that we need to keep going, right? Because there might be like smaller, bigger, and then some other stuff. So smaller, bigger, all we know now is we can just keep track of the bigger number as we go, and that's fine. And then we can have some other stuff here, like we can have some smaller or whatever. But all we need to do is just keep track of the bigger number, and then once we reach some other thing, we're gonna like do something there. But the other way, you can't just keep track of the smaller number, and you can't just keep track of the bigger number. Because basically we're gonna say we want to keep track of something as we go in linear time, and here we can't, right? We can just say like, if this is the case, no matter what we add on, like if there's like a -5 afterwards, we know like, okay, once we hit this -5, obviously we can't do increments and decrements, but we know how much this whole section costs, and we can just do that and then move on to the next chunk. Or yeah, but in this case, you like, what number do we keep track of, right? And so in this case, I mean, technically maybe you can, but that's not how I did it, at least. So in this case, what I did is I said, I'm just going to resolve this in chunks. I'm going to say, if this is the case, if this goes down, I'm going to say, once I hit this number, I know exactly how many operations I need for this chunk. And then now I'm just going to keep track of this new chunk. So I'm going to say, if it goes bigger than smaller, I'm going to add the difference to my result, right? So in this case, the difference is 1. And then I can just keep track of how much I need for this chunk. And then it's kind of easy. So here, I can just keep track of this number. And here, I'm going to add the difference to my result and then keep track of this number. So if we have a case like something more complicated now, let's say we have like this, or we don't need a billion numbers. Let's just say we have like 3, 1, 1. Or let's just say we have something like this. So I'm going to keep track of like how much I need to increment the current chunk and how much I need to increment the result. And so for the current chunk, like, let's say, I can scout draw this. Yeah, this is kind of what I was doing. So let's say this is our difference. And let's say our difference array is like, let's see, like 4, 2, 2, 1, -5, 8 or something. Let's keep going, I guess. 3, -6, -8. Okay, so I'm going to keep track of a couple things here, and this will make it easier to understand. I'm going to keep track of like my current chunk, and I'm going to keep track of a sign and my result. So the current chunk cost here is going to be 0. A sign we can just initialize to positive, and a result we initialize to 0. And as we go through here, we're basically we want to only keep track of how much we need to increment the current chunk. So if we can't combine the chunks, then we're going to like put in how much we need to calculate the old chunk into the result and just store the current chunk. So here, so this takes 4. So right now we can just say the current chunk takes cost 4 and it's positive. We can keep going. So here, like I said, if it goes from big to small, we can't keep track of how much we need to increment this, because we can, but what we can say is like, well, this will take 2 more operations than this, so we can just add that to the result now. And now our current chunk, we only need 2 operations left. And now we are keeping track of how much we need for the current chunk. So here it's the same number, so we can increment these together in our current chunk, which we can. Now here, same thing, this is smaller than the previous, so we're going to say, okay, what's the difference? Just 1, so we're going to add 1 to the result. And now our current chunk is 1 operation, which it is. Okay, now we hit a number that's a different sign. So we can't increment and decrement together. We have to pick one. So anytime we hit like one was positive, one was negative, we have to basically get rid of our chunk again and then go to our new operation. So our current chunk takes 1 to increment. So we're going to add that to the result. Now our sign is negative, and our new current chunk takes 5 operations to decrement. So then we go over here and we're going to say, okay, it was negative, now it's positive. So we're going to handle this chunk now. And that's basically the idea, is you need to keep storing things in the same chunk while you can, but if it's not possible, then you can just get rid of it and you add a new chunk. So here we need to add 5 operations. So 9. Now our new current chunk is 8 and our sign is positive. Now we have 3, so we can't do these together, but we can say, okay, now we know for sure we can just allocate 5 to this, and now the rest of it takes 3. So we can allocate 5, so we have 14, and now our current chunk is 3. Then we have a difference of signs, so we change the sign to negative. We do our current chunk, which is 3, so 17, and now our new difference is 6. Now here, like I said, this is basically the same as the other way where you go from 1 to 2. This operation will handle the previous chunk. Like if this takes 8, this whole thing will take 8 as well. So all we have to do is just update our current chunk. And then finally, once you're done, then you just take your current chunk and add to the result because you have no more chunks at 25. And like I said, this will take 8 because you can just allocate 2 here and then 6 to the whole thing. So you can do like 1, 2 to get this down to -6. And then 6 to this whole thing. So that's basically all it is. You just break it down to chunks, and if the sign is different, you put in your chunk, but you try to keep all your stuff together as you can, because the minimum number of operations is going to be taking things that can be done together and doing them together. And yeah, that's like the greedy subarray you pick. You just start at the start, and you see like, okay, while I can keep doing things together, let's keep doing it together. But if there's a clear difference and I can't do it together, then I won't. So here we go. We have a result, current chunk, positive, true or false. We get our difference. So this is our current difference. We get the sign. If the signs are different, just add our current chunk to the result. Otherwise, if our current difference is less than our previous difference, so I guess this is probably bad. So current is actually previous difference, and current difference is actually diff. So if our previous difference is bigger, right, like if we go from 5 to 2, then we'll just say like, okay, we'll just take care of this 5. That'll take 3 more operations. We can add that to the result, and we're going to store the 2 and keep going. And so that's basically what we do here. And then we just update our current and sign to the difference and the sign. And finally, we're going to have some chunk left at the end once we're done, so we just add that to the result. So definitely not an 8-point problem. You can just look at it and look at these examples, and it should be not too bad. Okay, so let's go through the complexities for all this stuff. So this is n and 0. Oh, whoops, I don't know why I wrote that. And is this. Yeah. This one is n and 1 as well. This one is n and 1 as well. And the same here. Okay, and it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.